Ready.
So today, we're going to continue working with grafting. So let's review kind of what we did like last time. We had a whole bunch of stuff here, so it's not on your paper. We're just going to kind of look at it. So a coordinate pair. Somebody's like singing a little song or something. Just shush. Are you listening? An ordered pair, coordinate pair. Can we stop talking for 1 second? Can we stop talking during the whole lesson? Yeah. So, coordinate pair, we also call these XY pairs. We call them, what else do we call them? Ordered pairs. This is X, this is Y. What's the special name we give to that one? Yeah? Origin. The origin. An X value, we learned some new fancy name for it. Remember what it is? Remember?
X-intercept. Domain.
No, that's not the one I'm looking for. No. Start today. Abyss. It's kind of like falling in an abyss. It's like when your tooth hurts. An abscess. I think that's how you spell it. And then you remember what the Y value was called?
Origin. Ordinal.
Ordinate. Abscess and an ordinate. Those are like new names. So if I'm looking at this ordered pair, this coordinate, -2, 4, what quadrant does it live in? -2, 4, what quadrant? Ryan.
Quadrant 2.
2. And then how do I write quadrant 2? Yeah? You have I, right? We're using Roman numbers. Always Roman numbers. So this one's 1, 2, 3. We make that kind of counterclockwise rotation around there. 1, 2, 3, 4. How do you plot a point? Who can tell me in words how you plot a point? Nobody. Uh-oh. Yeah, how do you plot a point? Yeah. Well, first of all, let's say I'm plotting this one. Where do I start? Which one? Well, I started the origin, right? And then what? I look at this gun. And so what is that telling me to do? Go left, because it's negative. If it was positive, I'd go right. Go left 2. And then what does the 4 tell me to do? Go up 4. If it was negative, I would go down, right? That's how you plot a point. Points on the x-axis are called x-intercepts. So here's an x-intercept. Points on the y-axis, yes. Y-intercepts. So this would be a y-intercept, right? So relation versus functions. A function is a relation where every x value has like y value. What goes in there? Oh, what goes in there? One person. Seriously? Where are you the only one that knows this? What is that?
Has one and only one y value.
One and only one. You guys like this. You're going to stand it back. Remember, one and only one. Get to your end. Okay, let's see. The blank is the set of all input values. Yes, sir. Domain. And what is the set of all alpha values, Matthew? The range. Don't confuse this range with the statistics range. That's a different thing. Okay, got it? Okay. So now let's go on to our linear equations. Linear equations have 2 variables. Doesn't change. We're used to equations that look like this. 3x plus 2 equals 7, right? That's the kinds of equations we're used to seeing. Now we're going to look at them that have 2 variables. This one only has 1. So here is a standard form of a linear equation. ax plus by equals c. Wow, how many variables are that? 2.
All of them are variables.
They're all, well, how many variables? 5? You know what? That's a trick question. It really is 2. Just the x and just the y. Just the x and just the y. So what's the ABC? These are what we call literal equations. And that just means that it's kind of like a format. These are like little placeholders for a format. So I can have an example of a linear equation in standard form. 2x plus 5y equals 8. Does it match this format?
Yes.
And if so, then what's the A, and what's the B, and what's the C? Yeah, what's the A?
2,
And what's the B?
5,
And what's the C?
8.
Yeah. Does that make sense here? So AX plus BY equals C. So if you see anything in this format, it is a linear equation in standard form, because there's other forms of linear equation. And you can tell who the A, the B, and the C is. What if, oh, let's just do a real quick one. What if I had X minus 4Y equals 0? Now what's the A for this one? What's the A? 1. I don't see a 1 there. It's there. It's invisible, right? If 1 times X is X. What? What's the B?
4.
Is it 4? Does that look like plus B? Careful, careful. Negative 4. Yeah. And what's C? 0. Okay. So you look and you try and match that up with AX plus BY equals C. And those values can be important sometimes. Questions on that? The negative, that can be a little tricky. All right. What is a solution to a linear equation in 2 variables? Well, what do we call a solution to one like this? What's the definition of a solution to this equation? Definition now, not what is it? Like what is the x value? What is the definition of that? What do I mean when I say find the solution? What do I ask you to do? What? Solve the equation. So what does that mean, solve? Solution. Like what is that? What are you trying to find? The answer. The answer. What do you mean by the answer? Yeah, you're right, the answer. Find x.
The variables value.
Find the value of x that makes this equation come true. I'm going to change this slightly because I don't like it. Let's make it 8. I'm just going to make it an 8. 3x plus 2 equals 8, right? So we subtract 2 using the subtraction property of equality. Divide by 3. This is the solution. If you plug 2 in, you get 3 times 2 plus 6. Is that 8?
Yeah.
Yes. It makes this equation come true. So you're looking for values that make it true. So it's the same thing with x, y's. I need an x and a y that make the equation true. So I say that one solution is negative 1 comma 2. Now how do I know that? So I'm still using, let me just get rid of some of the mess here. I'm using that 2x plus 5y equals 8. Now how did I know 2 is a solution to this top one? I plugged it in, right?
Yep.
So I'm going to plug it in too. This is x and this is y, so it's just an ordered pair like we know. So if 2x plus 5y equals 8, then I plug in what I think x is here. It's 2 is negative 1, plus 5 with y is 2. And then I'm really asking the question, is that 8? Let's see if it is. 2 times that's negative 2. That's 10. Is that 8?
Yep.
Now you probably see it now. To prove something is a solution, I do want you to go number to number. 8 is 8. Yes. This is a solution to this. I found it. Right? So I answered this question. How would we prove it? You plug it in. Plug it in and get a true statement. If you get a false statement, it's not a solution. Just like asking here, is 0 a solution to 3x plus 2 equals 8? No, because if I plug 0 in, I get 2 equals 8. That makes no sense. You have a question?
Yeah. So, would you just do multiple solutions?
Well, can you?
Yeah.
Are there any other solutions? I don't know. Let's think about that a little bit more. Because this one, I think there's only one solution, right? Can there be more than one? So let's look at this. Let's just check this one. I've got a different one here. It's 3x minus 7, or 3x minus y to 7. Is this a solution? Let's find out. So here's your x, here's your y. And I did it for you on the paper, so you can just look up here and watch how you do it. You plug in the x and the y. Then you do an evaluation. And 9 minus 4 is 5. Does that equal 7?
No.
No. So is this a solution?
No.
No, not a solution. It doesn't make the equation true. Let's try this x and this y. So 3 times 1 minus my y. Now look how careful I'm being with the parentheses. 3x minus y equals 7. My y is negative. As long as you keep your parentheses whenever you substitute, you should be able to keep that straight. So 3 times 1 is 3. What's a negative negative? Plus. I know you see the answer, but I want you to do that math. 7 equals 7. So is this a solution? Yes. Okay. Now getting back to this, are there other solutions, which is Sam's question. Let's try some of these points and see. So here's some other xy pairs. Well, let's give it a try. So we're going to have here 3 times 2 minus y. Does that equal 7? Right, I plugged in yes, I plugged in y.
Yes.
That's a 6. Negative, negative is a 1. 6 plus 1 is 7. They match on both sides, so yes, it's a solution. Let's see if this one works. 3 times 3 minus y. Y is 2 here.
Yes.
I'm just plugging it in here.
Yes.
So I'm getting 9 minus 2. Oh, that one works too. So let's try this one. 3 times 4 minus 5. That's the x, that's the y. Is that 7? 7 equals, it does. So that means there's how many solutions? So far, I found 4 of them, right? Because this one wasn't. So does any ordered pair a solution? No, because I found some that don't work. So how many more? Is this it? Did I find them all? I just kind of stumbled on it. Can we find another one?
Yeah.
Can we find, well, what's another one? Anybody have an idea? Here's one. See if this works. Does that
Yep.
work?
Yep.
Let's see, let's plug it in. That would be 3 times 5 minus 8. Does that equal 7? How did I come up with that? Where did that come from? What? 7 and 14. Does that work? Let's try it. Let's see. 3 times 7 minus 14. Is that 7? 21 minus 14. Is that 7? What's 21 minus 14? 7. Look at that. How'd you get that? Oh, what'd you do? You just plugged one in. You just tried every pair you could think of? Pretty much? Yeah, what do you think? Well, how are you getting these? Where are they coming from?
I figured that supposed to be wrong, but I times 5, 8, and 2.
So what are you saying, 10 and 16? Is that your proposal here? So 3 times 10 minus 16, is that 7?
No.
Is 30 minus 16?
It's not even close.
So this one's not a solution. Look, so some of them are and some of them aren't. How come I just picked one up there? How did Connor get one?
Yeah. 2 and negative 1.
Well, how are you getting these? Where are these coming from?
Right.
Oh, this one I already did.
Already did.
That one I know, that one is one. But where'd you come up with these numbers? What are we doing? What are you doing here?
Well, just like kind of bringing up these random numbers.
Just random?
Yeah.
And you're
Well, not
hoping
really
2 of them work?
No, like just thinking in your mind.
Well, what's thinking in your mind? What is your mind doing? I want to know
Working.
about this thinking.
Working.
There's some good thinking going on here.
Thinking process.
Yeah, what do we do?
Find out you can like share with like the factors.
The factors.
I mean,
Ooh. What do you think?
you can just pick a random number for x.
Okay. Pick a random number for x. So what's number we haven't picked yet? 8?
33.
All right, so let's pick a random number for x and leave y alone, right? So then I'm getting 24 minus y equals 7. I can subtract that 24, right?
Yeah.
So negative y equals negative, what's 7 minus 24? 7 minus 24, is that negative 17? If negative y equals negative 17, what's y? Multiply both sides by negative 1. Right? So you're saying then that 8 and 17 is another ordered pair. That guy gets a virtual gold star. Because that's exactly how you do it. How many solutions can I come up with then, Matthew? If all I can do is pick any x and kind of solve it for solutions are there going to be?
A gazillion.
All real numbers, meaning there's an infinite number of them. There are an infinite number of ordered pairs there to work. You know what? There's also an infinite number of ordered pairs that won't work. So I could sit here all day, right? And just plug x's in and solve it for y. It's going to take a long time, and I'll still never get them all. Here's why we graph. Because I'm going to make a picture of all the solutions. So graphs represent all those ordered pairs that work in a given equation like that with an x and a y. Graphs represent all the solutions that work. That's what all those little points are. So we graph lines so we can see all the solutions to a linear equation. Does that make sense? I think I want to say that again. That's kind of a really big idea. A graph of a line represents all these ordered pairs that we got to work. Because I can draw a line, right? And all those pairs, if you plug them in, they work. They make the equation true. That question? Oh, no question. Okay. So that's why we learn how to graph, to see solutions. So we're going to learn 3 different ways how to graph lines. And today we're only going to learn 1 way. Okay? And you already know how to do it pretty much. You guys okay over there?
Yeah.
So we already know how to do this. We did it last time. To make a table of values. We can do that. So where are we here? Yeah, we're in the bottom of the page now, page 1. Here's how you do it. It says y equals 2x plus 3, and I want to graph this because you know why? I want to know all the xy pairs that make this equation true. That's why I'm graphing. You with me? Who's with me?
Yes.
Everybody's hands not up. Okay, I'm worried. Who is not with me? It's you. Okay. All right. So here's what you do. You make a table of values. Now I'm like, well, what's this? Anybody have a teacher last year say, just put some numbers in, yeah? It's a pattern. It's just some numbers. Does it have to be these numbers? What could they be? Any numbers, right? Any number I want. So we generally say pick a few negatives, pick 0, pick a few positives, right? And here we got y equals 2x plus 3 is my rule. So I'm going to do what Matthew said. He said, why don't you just plug in the x and find the y? Good idea. That's what he said to do. That's how you find the xy pairs that work. So I put the x in, and that should give me my y value. So let's see, 2 times negative 2, that's negative 4. And negative 4 plus 3, negative 1, right? Negative 1, I'm going to plug that one in too. So let's see, that's negative 2 plus 3. Plug in a 0. 0 is always easy, right? 2 times 0 is 0. What's left? That's 3. 2 times 1 is 2. 2 plus 3, 5. 2 plus 2 is 4 plus 3 is 7. So let's see, that's negative 2, negative 1, negative 1, 1, 0, 1, 2, 3. 1 goes up to 5, I'll count right here, and then 2 goes up to 7, right? We did this last time. And then you connect the points. Hey, wait, what? Wait, just stop. You said last time, Mrs. Grieser, do not connect the points. Who told you to connect those points? Last year? What? You know, your teachers are all the same. You tell us one thing, you tell us another. Our heads are spinning around. What? Yeah, exactly. Claire's hair is spinning right around the circle I saw. So, are we doing this just to confuse you?
Yes.
Well, no, but it is a happy byproduct. No, so why didn't we connect the dots last time? And why are we connecting the dots now? Why? Yes. Now what are we graphing? Oh, this girl, I think I'm going to give you a virtual gold star. She is like, what? She said last time you're only graphing some points. So aren't I only graphing some points here?
No, you're graphing an infinite amount.
I am?
Yeah, you're including all your
I mean, what's my domain, Piyush? Domain is the key word here. If they don't say what the domain is, They just say graph this. They're basically asking you to find all the solutions to an equation. So this equation was y equals 2x plus 3, right? When they say graph this, they're telling you, find all the solutions. You're like, okay. So to find all the solutions, I'm going to use a domain of all real numbers. Unless I'm told otherwise, that's my domain. So can I enter every single x value? No.
Oh, yeah.
I just pick some of them. I pick a sample of them. These are a typical sample, a few negatives, 0, a few positives, until I see the pattern. Now this line says, and there are arrows here, it's a little hard to see, this line extends forever, and every point on that line will be a solution, that xy pair, that makes this true. Yes, sir?
Will it be array if there are no negatives in the table?
You don't have to put negatives in. You can pick any real numbers you want.
And how will it be array?
How will it be a what?
Array.
What do you mean an array?
Array, like,
This is not an array, these are xy pairs.
no, array.
Oh, just array, we're going to get to that. Okay, I thought you were saying array, like an array. Yeah, we'll talk about that in a minute, okay? Unless it says otherwise, domain is all real numbers. So when I look at some other examples here, like on the back, it says graph this equation. Now it doesn't say what the domain is, so that means find all the solutions. Basically saying find all the solutions that work, all the xy pairs that make it true. Okay. That means I have to know for every x value what's it going to look like. So I pick a sample of values. Now again, I like the -2, the -1, the 0, 1, 2. It doesn't have to be, but it is nice to see what's happening on the negative side of the axis, what's happening at 0, and what's happening on the positive. So we're going to plug that in. -3 times -2 plus 1. Negative times negative is positive, right? So 6 plus 1, 7. Plug in a -1. -3 times -1 is 3 plus 1. 4, right? Plug in a 0. That was kind of easy. You get a 1. -3 times 1 is -3. -3 plus 1 is 2, right? And then -3 times 2 is -6. -6 plus 1, -5. Do you agree on that? Going a little fast here. Just for last, whoops, I forgot to bring up my copy, never mind. So we're not going to laugh this time. -2. 1, 2, 3, 4, 5, 6, 7. -1, 1, 2, 3, 4. 0, 1. 1 is -2. And 2 is 2, 3, 4, -5. Now why am I connecting the points this time? Why?
Because they don't give you the domain.
Well, they do give you a domain. What is the domain? It's an implied domain, which is all real numbers. Right? If it doesn't say, there's still a domain. The domain is all real numbers.
It's not stated.
It's not stated, so it's implied. If it doesn't say, this is what they mean. Now, if this had been different, if this question had been, here's the equation, and this is the domain, would I be connecting dots? No. Then it's saying these are the only inputs, so I only want to see the matching outputs for this. I mean, does that make sense? Raise your hand. Yes, it makes sense. Okay, so if it's not making sense, ask the question. Is everybody raise their hand? Yes. No, she's like, don't raise my hand. I get it. Okay. I guess I'm really just trying to get you out of that automatic pilot where somebody says, do this, do this, do this. I want you to really think about it. Why? Now this is a good one. And this is star one. You want to like star this example. It's going to be really, really important. We're going to graph the equation y equals 3. So again, what's my domain here? 3. No. What's my domain? Any number I choose. All real numbers, because it didn't say. Right? Did it say? No. So I can pick anything, right? So Brian, what should I pick? Yeah, let's go with our usuals. Great. So -2, I plug -2. Wait a second. Wait.
Whoa.
So all the y.
Yeah, look at that. It's shouting negative 2. I wonder what y is. See how it's yelling at you? Hey, y is 3. Okay. My x is negative 1. What's y? Hey, 3. It's just shouting it at you. It's like, come on. I'm telling you. No matter what your x is, what's your y? 3. So let me go in here and just, okay, so that's negative 2. 1, 2, 3. Negative 1. 1, 2, 3. 0. 1, 2, 3. What's going on here? Connect the dots, right?
Yeah.
What am I getting?
Just straight line.
They're all straight lines. What kind of a line is this one, though? Horizontal line, right? We know about horizontal, like a horizon. Is it a function?
Yes. No. Yes.
Every input here only has one output. Happens to be the same output, but
Oh well.
so this is kind of important. Those of you that are talking are going to miss this important statement here. Whenever you see, what do you think y equals 10 is going to look like?
Big line.
Big line all the way up top, though, right? What do you think y equals negative 4 is going to look like?
It's gonna be all line all the way down here.
Y equals a constant number is always a horizontal line. Trust me, you will forget this. So I want you to kind of circle this example, put stars around it, because I want you to be able to flip back through your notes and say, oh yeah, we did this, I remember. Everybody putting big stars around this thing?
Yeah.
Exclamation points. This is important. You know what else is important? The next example. X equals negative 2. Now this one's a little strange. Because the domain is a little tricky. Because when I say, oh, it must be all real numbers, right? So let me put in some values. Negative 2, negative 1, 0. Wait a second, I'm saying something, and it keeps writing itself as negative 2. What? I couldn't control it. What happened? What?
It tells you the domain.
It's pretty much yelling at you, hey buddy, hey Skippy, x is negative 2. You can't put anything else here. X is negative 2. So you're like, well then what's y?
Any real number. Any real number.
It doesn't tell me. I can put 1,000 here if I want to. Well, what does this look like when you graph it? I don't know. Let's see. Negative 2, negative 2, negative 2, negative 1, negative 2, 0, negative 2, 1. Oh! What was happening?
It's not a function.
Not a function, right? You're getting, what kind of line is this one? Vertical. What do you think x equals 10 is going to look like? Think about this. These are all 10s now.
Like all the way up here.
I'll go this way, right? Like wherever 10 is, right? Isn't it? What about x equals negative 7? Down here somewhere. X equals 50. Way out here somewhere, up and down. So these are always vertical lines. Are you putting stars and exclamation runs around this one?
Yep.
Yep. Because believe me, when you see this again, you're going to be like, what? And I want you to be able to scroll through. Oh, let me take it back. I got this. I remember this. This is important. So is the other one. Because it's not really that it's hard, but for some reason, it sometimes causes a mental block for some people. What's the domain here? Goodness gracious. What's the domain? For this particular one? No? It's just negative 2. And what's my range?
All your numbers.
That's all real you guys got. Yeah. Interesting. Not a function though. Is this easy? Let's hope so. Alright, now, where's my friend with the ray? You can limit domains, right? Domain is an important thing. So if they don't tell you, you're just saying it could be anything. Well, sometimes it can't always be anything, right? Very often, like if you're graphing stuff in physics, you're working against time. Generally speaking, time doesn't go negative, am I right?
Well,
I hope not.
I hope not.
we
Well,
won't go back.
I
I
don't.
don't know, sometimes you want to do something over. No, you know what, no.
Like a test.
We want to go back in time.
We don't want to go back. Well, we can't. So we can argue about it, but we can't. So if you had a domain of time, you're not going to have negatives, right? So we can limit the domain if we need to. So I'm looking at these examples on the bottom of page 2 here. Graph the functions with a limited domain. So here it is. The y equals negative 4x minus 3. And here's my domain. And I'll put it in set building notation. Just get used to looking at it like that. It says x is number such that it's less than or equal to 0. So when I choose some sample of domain members, what am I going to choose here? Am I going to choose everything? I definitely want to pick kind of that limit here of 0. You definitely want to have that one in there. Can I pick 2? Why shouldn't I pick 2? It's not in the domain. 2 is not less than or equal to 0. So I'm probably going to pick only things that are in the domain, which is 0 and anything smaller. You can pick other numbers as long as it's in the domain. And then I'm going to plug these x's in. So negative 4 times 0 minus 3, that's the easy one, right? Negative 4 times negative 1 minus 3. Negative times negative, right? That's 4 minus 3. Looks like a 1. Negative 4 times negative 2 minus 3. Well, that's 8 minus 3. Right? Am I doing this right? Let's see. Negative 4 times negative 3 minus 3. Negative times negative is 12. Minus 3. Negative 4 times negative 4. 16. Oh, that's a 3. Minus 3 is 13. So that's what I'm going to graph. 0, negative 3, negative 1, 1, negative 2, 1, 2, 3, 4, 5. What else we got here? Negative 3, 6, 7, 8, 9. I'm kind of off the paper here, so it's up here someplace, right? But can I see my pattern? Okay, so now when I connect these lines, I'm only going here with my arrow. And I'm not putting an arrow here. Why am I not putting an arrow here? Because let me go back here, I didn't even mention this. Why are these arrows so important? Yeah, why are these arrows so important? Why is that, Brian? Yeah, this says you're showing the entire domain here. You're representing the entire domain. Well, I want to represent the entire domain here as well. If I were to put an arrow here, what's that saying? If I put an arrow here, what does that mean, Ryan? What does that mean? It means that this line extends. Even though I didn't draw it, the arrow says it is. So I don't want an arrow because it doesn't extend, because nothing here is in my domain. So now can I figure out what my range is? The range of this guy. Yeah? Yeah. So where are all my y's, right? Nothing, nothing, nothing. Oh, here's some y's, right? So, Brenda, what kind of inequality can I write to describe this range? What's this value right here? 2, that's negative 3, right? So what can I say about my y's? What? Yeah, please don't shut up. Well, don't worry about the bar yet. I just want the inequality. It could be negative 3, right? That's a possibility. Is it less than? Start with y. Is y bigger or smaller than negative 3? Bigger. Can it be negative 3? Yes. There we go. There's my inequality. And then you just turn it into your set-builder notation. That's your range. Yes? Yeah. Let's try this last one. Question?
Yeah. He has a question.
Yeah, I was just zoning out. I have the answer. Is that what you got?
Yeah.
Yeah, what's your question?
Why don't we have an arrow for
Why don't we have an arrow? Great question. Why? Think about it. What happens if I put an arrow here? What does that say? And that means that there are points here, right? Is this in my domain, this value? Or this value? Or this value? Look at my domain. Not in there. So I can't put an arrow there because otherwise, here's my domain. We draw my domain. Right? This is my domain. So I can't include any points that have these x values, because these x values are not in the domain. Right? We said it before, it's worth repeating. Those arrows really mean something. You have to think about when to put them and when not to put them.
Why did you put arrows on the other problems that have?
Yeah, okay. Why did I put arrows on the other ones? Why? Well, what is the domain? If I don't state it, what is the domain? All real numbers. So I need to extend it because all these x's are inputs. Right? So I have to show values for all of them. But in this case, they are not all inputs, so I don't put a value there. Look at this little string mark here. Yeah? Let's do another example. So here I've got negative a half x plus 1, that's my y. And the domain is x bigger than 1. And I'll put it in set builder notation just so we can see it. So let's see, I have to pick some values of my domain. I do like picking the actual limit right there. You know, where's that place that it starts or stops? And then what would be good choices here? Yeah, what do you think, Ryan? Can I do 0?
Yeah.
X bigger than 1.
Oh.
So what should I put here?
2.
Claire?
1, 2, 3, 4, 5.
Okay, 2. And now I can put all those things. Look what I have to do. I have to take half of it. I like 2. Do I want to put a 3 here? Now I could. But 1, why don't I choose 4? I know how to take half of 4. It's easy. I could choose 5, but then I get 5 halves. You guys told me I hate fractions. Why don't I choose something that's easy to take halves of? So I didn't for 1 because I wanted to have kind of, that's my kind of domain point. So I'll work with it for 1. So I get negative 1 half times 1 plus 1. Negative half plus 1. Well, that's just a half, right? 1 minus a half, that's a half. All right, we did the hard one. Negative half times 2 plus 1. That's this one, right? What's half of 2?
1.
1 is negative, right? So negative 1 plus 1. 0. What? I'm just plugging numbers in. Negative half of 4 plus 1. What's half of 4?
2.
2, but it's negative, right? So negative 2 plus 1.
3.
Negative
1.
2 plus 1.
Negative 1.
Negative 1. All right, negative half of 6 plus 1. What's half of 6? 3 is negative. So negative 3 plus 1. Negative 2. Negative half of 8. Negative 4, right? Plus 1. Okay, now I can start graphing, right? So I go 1, and I have to estimate where half is. Let's start here. 2 is 0. Then I go over to 4 for negative 1. Then I go over to 6 for negative 2. Then I go over to 8 for negative 3. Now when I draw my line, Aiden, am I going to make a big giant line here with 2 arrows?
No.
No. What am I going to do? Where does the line start? At what x value?
Oh, 1.
1. So I start here. Oops, I'm missing my point. There. There's my arrow. This is an N.
Oh, okay.
Yeah? All right, now, what's the range? Oh, dear. All right, so that's going up and down, right? So let's see. Nothing until I'm like here. So what's that y value right here? Positive half, right? Am I bigger than a half or smaller than a half? Bigger's up here, right? So I'm smaller. So y is less than a half. Can it be a half? Yeah, so less than equal. And then I just turn in my set builder notation. I got my range. Is that a function? Yes or no?
Yes.
Yes, every input has one and only one output. Yes, it's a function. Question? Who gets it? Give me a 1, 2, 3, 4. 1, no! 2, little, 3, I'm kind of there. 4, let me teach it next time.
Okay.
I'm looking. Not too bad.
You're not 3.5.
Right, I didn't see. I still can't. Once you guys keep doing it.
Oh.
Okay. Good. Excellent. That's all you got to do.